So converting from square units to cubic units, or square units rather, or cubic units, we can't just use the fact that there's 1,000 millimetres in a metre, because it's a square metre. So you have to take that into account. So that comes up in all the questions in this exercise that you've been looking at, this question here. So this little bit of video, I'm sort of thinking in the video now, is sort of around this and addressing issues to do with it. So you've got the density that's going to come into it, and also the idea of converting from one unit to another. Look, if we look at question number 3, 120 metres, but a width of 150 millimetres, so you've got to do some converting units. We've got the dimensions in millimetres, but we want the answer in cubic centimetres. So again, the issue around units. Okay? So there's a choice when we do these things. I would always recommend that if you've got a problem to do, looking at number 1 on here, for example, if I want the answer to be in cubic centimetres, and there's a reason why I want cubic centimetres here, because the density is given to me in grams per cubic centimetre. Can you just focus on what I'm saying here, because it might be important to you, okay? So it's not, the reason why I go to cubic centimetres is not because the question is particularly asking for it, but it's because if I'm after the mass, which is really at the end of this question what I'm after, to find the mass I need the density. So I'd look that up in the table of values and find that the density of this particular material is 9 grams per cubic centimetre. So that's telling me, first of all, that the formula for density is mass over volume, because the mass is in grams, volume is in cubic centimetres. So if I don't remember the formula, that's telling me density is mass over volume, grams over cubic centimetres. First thing. Second thing is, I've got to find the volume of this thing, and it must be in cubic centimetres because the density is in grams per cubic centimetre. And when I find the mass, that's going to give it to me in grams. So the units are really important. So now I know I've got to find the volume of this thing in cubic centimetres. So if we look at question number 1, I'm given that the dimensions are 40 by 25 by 15. 25 times 15. And that's in cubic millimetres it's going to be, which I then have to convert to cubic centimetres. And I remember that there are 10 millimetres in a centimetre. But, as we were discussing down here, a cubic centimetre is 10 by 10 by 10. So how many cubic centimetres, how many cubic millimetres are there in the cubic centimetre? Nope. 10 by 10 by 10. 1,000. Okay? So if I do 40 times 25 times 15, I then have to divide by that by 1,000 to get it to cubic centimetres. So I don't make that mistake. I would always recommend, and I do this myself, if I want the answer in cubic centimetres, convert that to centimetres at the start. So instead of it being 40 millimetres, it will be 4 centimetres times 2.5 times 1.5, and I'll automatically have the answer in cubic centimetres. A good tip, okay? Get your units in the right form at the start, and then you won't fall into that trap. Now, question 4 I want to look at, okay? So I want to look in detail at question number 4, this one here. So get that one there in front of you. Calculate the volume of a metal tube whose outside diameter is 8 and whose inside diameter is 6 if the length of the tube is 4 meters. First problem with this question is inconsistent units, centimeters and meters. So let's leave that in centimeters and convert that to centimeters, 400 centimeters. Okay. if only because the answer's in cubic centimetres. So let's have everything in centimetres rather. Okay. Second point, draw it. When it comes to the assignment, I want to see your working laid out. I maybe mentioned this already. Setting out the problem is very important so that it makes sense to anyone else who's looking at it apart from you, i.e. me. So if you draw it, that helps. You're now given the outer diameter. So the diameter of the outer part of this is 8 centimetres. The diameter of the inner part of the tube is 6 centimetres. This is how you might set it out. Remember that symbol for diameter, and the length is 400 centimetres. Now the process for this, and we've been discussing this as we're going around, what would I now have to do to find the volume of the tube? And do what?
And then if you take it away from the, well, you know how much is like taken slightly.
Yeah, I think I know what you're saying, Daniel. Yeah.
If you like work out the outside, work out circle.
Yeah. Yes, that's right. I'd find the volume of the outer, of the whole cylinder, effectively, and subtract the volume of the inner cylinder. Or I could just do the area. What's the area of this circle? Subtract the area of that circle will give me the area of this bit. Remember, the volume of a pyramid is just the surface area of the end times the length. So I want this area, and that's a perfectly valid way of doing it. The point I want to do, though, is to show you formula-wise how this would work, because it might make some sense to you, and you might start to see how these can be useful. So the volume equals pi r1 squared times the length, where r1 might be, or ro for the outer cylinder, minus pi r inner squared times the length. That's what that's saying, isn't it? That's what we're effectively doing, finding the volume of the outer cylinder and subtracting the volume of the inner cylinder. That's an expression on the right-hand side here. And it's written algebraically, find the volume of the outer cylinder and subtract the volume of the inner cylinder. Are there any common elements to those two terms? Pi, and not r, because r0 and ri are different, so what else is common? No, because the r1 0 squared and ri squared won't be the same. L. So I can take pi and L outside a bracket, leaving just the radius of the outer cylinder squared minus the radius of the inner cylinder squared will give me the volume of that tube. So in other words, I've got a general formula to find the volume of a tube. Now you don't have to go through all this process anymore. You could just work out what's the radius of the outer tube, the radius of the inner tube, and plug them into this formula. A shortcut, if you're doing lots of these things, you could do it either way. I'm not saying you must do it this way, but I'm just trying to point out to you the power of algebra in simplifying the problem. And I hope you can start to see how that might help. Okay?